Hi, this is Mona. I'm introducing this question from chapter 17. First, we can see those numbers given in the picture, the mole of weak acid, acetic acid, and of sodium hydroxide. And we need to determine the pH before and after equivalent point and at the equivalent point. So we can first do this by drawing a diagram. And of course, this is a titration problem, and the weak acid is titrated with the strong base. So we first start with lower pH and then pH beyond 7. And the equivalent point is still above 7 as this weak acid. And we can see the volume and pH as those x and y axis. We first calculate the equivalent amount for the strong base by using this formula, and we plug in numbers, then we can get those the eventual result is of course 1 molar equals to this amount of mole per liter. This is unit conversion, as we remember. This number 0.0168 liter is also 16.8 milliliter. And next step, we need to determine it before the equivalent point. So we calculate the mole of the weak acid. By use this formula, the concentration multiply the amount of volume, we can get the mole of weak acid in this. And then we also calculate the added strong base by using the similar formula. And you can see the number of moles we get, which is 6.25 times 10 to the negative 4 mole. Then we can subtract the strong base added to get the lefted amount of weak acid. So then we can calculate it by subtract those two numbers we get. So we calculate the left mole of this weak acid, which is equals to the number we get. And then we can use this Henderson-Hansel equation to calculate pH. And so we first need to understand what is the concentration of our acid, so we can divide it by the amount of titrant and amount of analyte. And to get the concentration of weak base, we can calculate it by use the number of the mole of the strong base as it consumed. So at the same time, we could use the conjugate base. So eventually, we can get the concentration of those two acid base, and we can eventually calculate the number. And of course, the pKa can be get from the reference sheet, and the eventual number is 4.381 as 3 significant figure there. For next question, we can first get the total volume. So we know our equivalent amount for weak acid and weak base. We can calculate this total volume at the equivalent point. And then we can get the mole of our conjugate base, because at equivalent point, we know that all the weak acid and weak base are used up as they are titrated, eventually produce this conjugate base and water as spectator ion. And we can get a concentration of a conjugate base by plugging in those numbers. And we know because only the conjugate base is leave, so we can use Rice table to calculate our OH, because the conjugate base can be hydrolyzed. So we plug in our number and get the Kb by use this formula, and because we are only given Ka. So it's necessary to calculate that, and we also set up our formula, and we need to check that if we can use our math shortcut. So we check that it is less than 5%, so we can use our math shortcut to ignore the x, which means x is small. So we can eventually get our x equals to this concentration, and it also equals to the concentration of our OH. So we can calculate POH by use log of it, and then we can calculate pH by using 14 minus POH. We get 8.75. And for next question, we are calculating the pH after adding 5 milliliters beyond the equivalent points. So we first calculate the total volume so that we won't forget this amount, because we add extra 5 milliliters, so we need to plug that into our formula and we can get our new total volume. And of course, we add excess OH after we use up all of the analyte. We have like this excess amount of titration. So, titrant. So we use the formula to calculate the X amount of OH being added, the mole of it. And it also equals to the amount of conjugate base produced, as we can see from this formula. And sodium is spectator ion, and this is our conjugate base. However, as we know, when there is mixture with the strong base and big base, we can just use concentration of strong base alone. So we use the formula as that similar to the mentioned before. Calculate the concentration of OH, calculate POH by plugging the number, doing negative log of it, and we can use 14 minus POH to get the pH, which is 12.175. Of course, it's also 3 significant figure, and the first number is the exact number. So to sum up, we first need to get the added base, the concentration of it, and calculate the mole of the selected. And then we can get the pH by use the Henderson law. And the second question, we need to calculate the left amount of conjugate base, and then use rest table to calculate OH and get pH. And for the last question, we need to calculate the excess base added, and based on that, we can calculate POH and get pH.